Evening. Welcome you all to the session 8 of our FDP on convergence of quantum computing and Gen AI for frontier scale revolution. So far we have been seeing about this quantum computing, and we just started with the generative adversarial networks we have seen. And in this session, last session, Grisha has given us about GAN, and he was discussing about the Databricks framework, and he was also discussing certain kind of problems related to this Databricks and how to proceed with this GAN. This is what we discussed in the previous session. And in this session, we are going to see about generative AI models and its trends. We have a resource person, Dr. Duriraj Vincent sir. Welcome you, sir.
Thank you,
Vincent sir is a professor in the School of Computer Science, Engineering and Information Systems at VIT Vellore. He's having around 17 years of teaching and research experience. He has also published around 111 plus papers, out of which 44 are SEI papers with a impact factor. He's having an average impact factor of about 3.4, and he has produced many number of PhD students, and he is also recognized as a top 2 scientist continuously for 2023 and 24. And his research areas include machine learning and deep learning, where he produced 5 research scholars in that particular area itself. Apart from this, he's delivered talks in many top institutions like IIT Roorkee, Anna University, Loyola College, and industry collaborations. Further, he is one of the co-principal investigator of DST funded project, which is of worth of 2.3 crore. It's a great pleasure to have you, sir. The session is yours,
Thank
sir.
you. Thank you. Shall I start, ma'am?
Yes, sir, you can start.
Yes. Yeah, good evening, one and all present here. So already it's a late evening. First of all, let me thank the wonderful organizers, Dr. Prabhadevi ma'am and Shweta ma'am, for inviting me to give a presentation, a session on Gen AI models and trends. So next 1.5 hours, I hope I will be covering some of the important aspects of Gen AI based models and the present trends, as well as the future. So how we will be looking into the Gen AI in the next 5 to 10 years. So already you have completed a session based on generative adversarial networks with a hands-on session. So I hope that particular session will be very helpful to carry out this, because I need not get deeper into all these things which were discussed in the previous session. So before I get into the session, so this is an icebreaker where a prompt that I have given as part of the Gen AI, where a futuristic city on Mars with flying quantum computers. So this is what the prompt I have given for the Gen AI generator. So where in which I will be getting this particular outcome. So you will be able to see through the kind of innovative capability the Gen AI has with respect to combining various things, which may be completely an imaginary one. So we will be able to see to that how productive when it comes to this particular task, not just a task, but it is about to create something based on the existing one. So with this kind information, so let us move into the session about the different things we are going to discuss today. So this is the overall outline of the today's session. We are going to have an introductory discussion to Gen AI first, then followed by foundations and key terms. What are all the key terms we have corresponds to generative AI? Then we will be briefly discussing about some of its major models like GAN, VAE, as well as the diffusion-based models. Then we will be looking to the various types of generative models we have in terms of different data like text, image, video, as well as audio. Then we can briefly look into the multimodal models, where we can have more than one type of data we can generate. And while we conclude, so we will be looked into the challenges and limitations of generative AI in the present day scenario, with the concluding remarks of quantum perspective. So because the major theme of this particular FDP is quantum, so we can look into the quantum perspective, even though it's a very early to talk much about this, but still we can say what we can look into in generative AI with the help of quantum computing. So with that, we can wind up today's session. So what is generative AI? So every one of us very much aware of this particular context, especially in the last 1 or 2 years of the advent of ChatGPT and widely accepted one across the ages, across the domain, and across various professions. So generative AI, we can say that it refers to any AI model that can generate new content. So that is what we will be referring as generative AI. A new content could be a text content, or it could be an images or music or video, or even a code, any programming languages based code. So anything that we will be able to create out of the existing piece of information, so we will be calling it as generative AI. So for example, for the text, mostly we are using ChatGPT. Now we are having the capability to even generate images and even beyond that. So apart from that, Claude and Gemini are very popular with respect to text-based generation. Images, DALI again belongs to ChatGPT, as well as the stable diffusion are some of the ways we could generate the images. Audio exclusively by MusicGen and audio-based LM. And code, we have the GitHub Copilot, and for video, we have Sora and OpenAI, as well as the Runway ML. So these are all the present day scenario of generative AI, where we will be able to access to various contents depends on our necessity. So this is the global shift. So what we are seeing today is all about the global shift in terms of the technology. So earlier it was only about artificial intelligence. Later, machine learning. Again, it came under the name of deep learning. So in that particular context, so in the last 5 to 6 years, we are able to see the transformation in terms of Gen AI. First of all, the today's topic that we are going to discuss about, where we will be able to train the models which scale to the internet-based data. So internet data generation, we all know that petabytes of data is being generated on a minute-based scenario. So where the huge amount of data is being generated, and when we want to scale any model to the speed at which the data is being generated from internet, it is something exceptional that we could call. So which transforms the industries like education, entertainment, finance, healthcare, legal, as well as some of the creative arts. So we could see to that we will be in a position to see a larger impact with respect to that. So when we are working on the other aspects related to Gen AI, so we will be able to see to that there is an emergence of multimodal AI stuff. So multimodal AI is pushing Gen AI even beyond. So even beyond.
So
it is pushing even beyond. Yeah, even it pushes us to go beyond a particular data type, where we will be in a position to look into the content beyond one single data type. It may be the combination of text and images, or a video with the audio. So such kind of emergences is happening with respect to the multimodal AI. And finally, with respect to the rise of agentic AI. So agentic AI is again another transformation which is happening with respect to the field of artificial intelligence, which moves beyond the content generation to autonomous reasoning and tool usage, which enables the decision support, automated research, and even the interactive assistant. So the agents, it could interact with each other. So little later, so we can take up one example also that how we could relate this agentic AI in the AI perspective. So with this introduction, so we will quickly look into some of the key terms that we will be using across this particular discussion or throughout the particular context of Gen AI for the next 5 to 10 years or down the line. So the first one is the foundation model. So foundation model is a predominantly used context in Gen AI where we will not train the models every time. So we will be make the model available for any kind of scaling. So especially in the internet scale. So we'll be calling it as a large scaled AI models, which could be trained on vast, diverse data. It may be the combination of text, images, or coding, or whatever it may be. So we will be in a position to see that it has the capability of handling any kind of task. So it is not restricted to only a particular kind of task. It will be always accommodative to any kind of task with a very minimal fine tuning. So we need not look into the particular model building exercises quite often. So we will be able to see to that it will be working beyond certain limitations. So that we would be calling it as a foundation model. And transformers is really a revolution with respect to the artificial intelligence and the starting point of Gen AI that we would be calling it as. So it is the core architecture which is behind this modern Gen AI models, whatever we will be using in today's scenario. So it basically follows a parallel processing with the attention mechanism. So attention mechanism normally incorporates the long range dependency. So when we call the long range dependency, so we will be able to understand that one particular word may have the reason behind another word which may be coming out of that particular context even after 2 or 3 lines or after 2 or 3 sentences. So such kind of long range dependencies were taken care by the transformers in a very appropriate manner. So that is what the revolutionized invention towards this particular generative AI. Next comes the diffusion models, which is actually a very recent breakthrough in terms of image and video generation, where these kinds of models learn to reverse the noise added to the data, because the noise added to the data is one of the key thing when it comes to the generation of the newer data that you might have heard about an hour before in the previous session. So which is the key thing behind the data generation. So diffusion models is coming up with respect to this generative AI. So next comes the another key term called hallucination, which is something wrong with the Gen AI when it comes to the generation which goes completely opposite to our expectation, which could be incorrect, which could be cooked based on the cooked up data, or which could be made up one. So such kind of problems are very worrying sign with respect to this particular hallucination. So we will discuss about this in a little later when it comes to the particular part, the challenges involved with respect to this. Then the multimodal data, where we will be having a separate field called multimodal AI, where we may be in a position to handle multiple data items in a single model. So if ChatGPT is able to create text-based content, image-based content, a video file, it could create a code, it could create a music file. So if that is the case, we will be in a position to understand that it can capable of handling such kind of a variety of data with respect to the types it belongs to. So such kind of things is possible through this multimodal AI. Then comes the agentic AI. So agents are not new to computers. Agents were there for quite a long time, right? So especially those who are doing the trading, so they must be very well aware of the role of agents. So when it comes to buying or selling a particular stock, we will be able to instruct our agent when the particular price is being touched. You can buy a particular stock, and when the particular price touches another particular value, you will be able to sell that particular stock. So it is a command-driven agent, so that we have been using for several years. So in the advanced level, so agents are nowadays become autonomous in terms of taking decisions, where it will be able to take a call on its own that in what price you want to buy a particular stock and what particular price you want to sell a particular price. So in that particular context, so we will be able to understand that we will be in a position to understand that such kind of things are going to be the future. So in another context, if I want to understand a better way how agentic AI could help, so we will be able to understand that if we are in a position where if we want to book a flight ticket, for example, so we want to travel to a particular country, for example, let us say Dubai. So if you want to travel to Dubai, so you can assign an agent, and you can give all the instructions to your agent. So you can give an instruction like in the month of March, April, May, in this 3 month, you can ask the agent to select a particular week based on the estimation that the temperature could be somewhat okay in that particular week. And again, another condition you can give that what would be the price of the flight tickets. So you will be giving two different conditions, and if you are talking about a lowest price, then the agent is going to have two conditions to satisfy. First thing is about the climatic condition. Second thing is about the price of the ticket, which could be a reasonable one or lowest one among the 3 months or something. So it will be able to interact with several tools, maybe weather API or any ticketing agents API or something like that. It will be able to interact with that. So in addition to that, for example, Dubai is another country, so where you may require a visa to travel that. So in that case, it may be in a position to interact with another agent as well. Maybe you can imagine that an agent which may be exclusively handling for visa related things. So whether your visa is a valid one or you have to renew it or something like that. So now the particular task is given to the particular system, whereas the agents are interacting between that, and finally you will be able to get a complete package with respect to all your needs and necessities, and in a more effective or efficient or in a very reasonable price. So all those things will be satisfied. So now the interaction between the visa agent and the ticketing agent and all these things will be interacting with each other. So that is what people are nowadays creating such an environment under the name called agentic AI. So which is also going to make bigger waves in terms of artificial intelligence by bringing a lot of futuristic changes in the different industries. And finally, about the quantum generative model, so which is really in the very early stage of research models, which would trying to combine the quantum computing with the generative AI by having some potential offerings in terms of generating the new data, optimize the outputs, and simulate the creativity. So that we will discuss towards the end of this particular discussion. So before we move further, so let us look into the evolution of generative AI, because several evolutions are happening with respect to AI. We have to look into various aspects with respect to that. But when it comes to the generative AI, so we have to look back from the rule-based AI, which was there since 1980s. We have AI which was working on solving some of the problems based on the rule-based or rules that are generated out of it. Later, it has become machine learning with various capabilities. So we have been seeing machine learning for quite a long time. Then the deep learning comes based on the neural networks. now we are having the generative AI. So if you look into the timeline for the last 15 years, so pre 2010, it was all about the discriminative models in terms of classification and prediction. But in 2014, GAN was introduced by Ian Goodfellow, which was the first wave of a generative breakthrough, which happened more than 11 years ago. And in 2017, the introduction of transformers revolutionized sequential modeling, which is the foundation of the large language models. Then between 2018 to 20, the rise of GPT, BERT, and all kind of language models have happened. And between 2021 to 23, we have this diffusion models, multimodal AI, Dolly, ChatGPT boom, everything has happened. And in the last 1 year, we are able to see in the name of agentic AI, multimodal foundation models. Already the models are being ready, which will be readily available for any kind of transfers that required in the futures, as well as the quantum curious Gen AI, so which is also started coming. So what is the backbone of Gen AI is the self-supervised learning. So self-supervised learning is an advanced version of supervised learning, because we all very well aware of supervised learning, that how it has happened. But supervised learning, as we all know, that the labeling would happen each and every time. So that is what the time-taking thing when it comes to the supervised learning. So such kind of larger efforts or a tiring effort is completely eradicated in this self-supervised learning, which allow the AI to learn like a human being by observation without the need of a constant labeling things. So these kind of generative AI models basically trained on this with a huge volume of raw text, images, and videos based on that, and which could be very helpful for us to have such a wonderful model which satisfies the data efficiency. So data efficiency is one of the most important part, as we do not depend on the labeling part when it comes to this particular process, which could satisfies the scalability aspect, because in the internet era, in the internet scale data, it is too difficult to satisfy that. So we have to see to that particular aspect, which works very well, because we are seeing on every day-to-day basis, we are working with that. So we know how well it works with, and which can train on the petabytes of internet scale data. So whenever there is a scaled up of data, we will be able to see to that the particular model has all the credibility, like transferability or creativity. So all these kinds of things, it will be in a position to satisfy. And finally, about the various pre-trained models like BERT or GPT, or all those things are belongs to the category called self-supervised. So now another important term with respect to the overall discussion today is the latent space. So which is also a very important part when it comes to this particular generative AI, because these kinds of data are very huge data. So we are working with a huge amount of data. It's not so easy to handle it. So it is necessary to be compressed. So from the convolution neural network process, so we have been looked into the way how we could compress the data, how we will be able to reduce the dimensionality of the data. So all such things we will be looked into without compromising the core information of the data. So in that way, latent space also works on the same aspect, that it is a compressed and abstract representation of the important features that we have with respect to our data, whether it is text or image or audio or whatever we would consider. So it's a mathematical space in which each point represents a set of features that defines a particular output. So we will be representing in such a way that instead of directly working with the pixels or raw data, these models operates in the space where it's more structured and meaningful, because we are basically working as an abstracted version of that particular data. So why it matters when it comes to the generative AI? Because the style transfer. So style can is one of the popular can you would have discussed in the last session. So where we will be able to create a lot of images by manipulating the things. So that kind of manipulation happens with respect to this particular latent space, so that we will be able to preserve the important information. At the same time, we will be able to create a newer content as well. So controlled generation is another important thing that we will be in a position to enforce the model to generate outputs with a specific traits by navigating this particular latent space, and which will be also enables edits with respect to the semantic perspective. So when we looked into the foundational architecture, this particular figure or the photograph was very popular because as we have discussed about style can. So this particular challenge was something very popular in the year of 2019. So by showing that which particular phase is real, because one particular phase is AI generated and another particular phase is the real phase. So this particular thing was done with the help of StyleCAN in the year 2019, which was actually by NVIDIA, which was actually a contest. A contest was given to the participants where people have shows that 48 percentage to 59 percentage of that particular observation goes against one with the actual one is with the against that particular thing, which means the people were equally splitted into 50, almost 50 percentage, that only 50 percentage of the people were able to identify the real face, whereas remaining substantial percentage of people have identified the wrong particular face. So the overall foundation behind the generative model is the data distribution. So as we have seen in terms of the latent space. So here the goal of this particular approach is to model around the P of X, the data distribution, rather than the normal classification model. Like if you give X as an input, we will be able to get Y as an output. So that's how we used to do in the discriminative model. So here it is not in such a way we will be working in a traditional manner. So the latent variables is the representation of the higher dimensional into lower dimensional by capturing the hidden structure. It's not like just simplifying things, but after capturing the hidden structure, it will bring down into the lower dimensional space. And the sampling will be helpful for us to learn that how one can generate the new samples out of this particular exercise. So there are two main categories with respect to this particular representation. One is explicit density model and another one is implicit density model. So VAEs and autoregressive models are belongs to the first category, and GAN and diffusion model belongs to the second category. So these explicit density model estimate the probability of X, that particular space, directly, whereas another implicit one, which will be not in a position to do that, but it will be able to generate the realistic data without computing explicit probabilities. So otherwise it will be trying to solve this, but not in this particular way. So that's what we are trying to understand from this. So with this basic fundamentals, we can look into the various ways we could see how the contents are being generated. So as I have mentioned in the outline, so we will be briefly seeing the text, image, video, as well as audio, the four different types of data, how the generation is happening in the present day scenario. So text generation refers to the automatic creation of human-like text by a machine based on a given input. As we all know, through a prompt, a partial sentence or context, that anything that we give, we will be able to get some output. How efficient and how effective is completely depends on the input that we give. So in this text generation model, the first one is the auto-regressive model, which generate text sequentially by predicting the next token. So that is how it has been started for a long time before. So it is truly depends on the previous one. The next token will be depends on the previous one. So which ensures coherence and context awareness in the generated outputs. But we all know that the revolution happened in the year 2017 by Vaswani and other set of authors in terms of transformers, which completely revolutionized the new natural language processing by enabling parallel training and efficient long context learning, which forms the backbone of model or modern generative AI that we would call it as. And based on that, we have several large language models, the LLMs, which are trained on the massive data, GPT or Claude or Gemini or whatever we would see. So which enables the high quality text to data generation. So this particular model outputs a probability distribution over the vocabulary. So a probability based solution it gives. So on a best probable way, which could be the next word in that particular way, it basically works. So some of the architectures, very well-known architectures, it's all started from RNN based generators, LSTM or whatever we would say in the past. So which has its own way of problem solving, but which was struggling with the long range dependencies because it is completely based on one particular token and the next token. So in that particular way, it was able to solve this particular problem. Next comes the transformers, where we were seeing that it was scales well with respect to the large internet-based data, and the context length were very appreciable with respect to the content generation. Also, we had encoder decoder model, especially for the translation from one language to another language. And in the recent time, we were seeing the GPT family as well as the BERT-like models. So GPT predicts the next token purely based on the auto-regressive way with respect to the self-supervised learning, which is great for the generative task like chat, story writing, coding, and all those things. When it comes to BERT-like models, which works with mask random tokens, which predicts based on the context, which is great for understanding tasks like classification or sentence similarity, which means it could not utilize for the other way of generative things. So this is the comparison between the various models that are available in today's scenario. So what is the self-supervised learning strategy with respect to each thing, and what are all the strengths and what are all the weakness with respect to each particular model. So RNN, as we all know that it captured local dependencies because it's all about one after another, which really struggles with long range memory because its capabilities are limited, whereas transformers needs a larger computing facility. So we know that millions and millions of amount of money is being spent on the computing facility, which is something very challenging when it comes to transformers. Uh, when encoder and decoder aspect, when you looked into, it is less fluent, free from generation when compared to the transformer, because it basically matching between one input and another output. So that kind of mapping we'll be doing. So GPT family has limitations with respect to context, whereas BERT-like models have certain limitations, like it could not be used for, first of all, the text generation itself. Whereas it has some strengths as well for our understanding that still all these are in usage. So next, when we quickly move into the next kind of generation, that is images and video, so which is very popular in the present day scenario, because with respect to text-based data generation, so we have seen quite a longer time with respect to that things, but only in the recent time we have witnessed these kind of models. So here the purpose of these AI models to create new visual data from the images and videos that we have in terms of noise, in terms of prompts, or in terms of other ways that we could input. So this could be used at a different perspective, like the creative content generation for art, film, gaming, designing. So it has plenty of applications in the present day scenario. So not only with respect to that, data augmentation is another field which largely benefited out of this. For example, when it comes to the model building exercises, we may not be able to get data for all types of classes. For example, we are working with a multi-class problem, so we may not sufficiently get the problem corresponds to every single class it belongs to. So in that particular case, we will be in a position to go for data augmentation with the help of the generative AI, which could be a very good solution for solving some of the key problems. And another way we could benefit out of it is the restoration and upscaling of low quality data, pictures, videos, whatever we have. So which could be very helpful in many cases, especially with respect to the law and order and all those things. It highly helpful for them to solve some of the key cases. And finally, the virtual reality and synthetic simulations or the other kind of applications that we could see out of these exercises. So when we looked into the major generative model family for all these contexts, it is not only limited to images or videos or audio. So these three are highly popular for all these modalities, like generative adversarial network, variational autoencoders, as well as diffusion models. So we will briefly discuss about each of these particular things. So even though you have just looked into the GAN related things, so I will quickly cover up these things, as we all already know that it was introduced in 2014, which is capable of generating data that belongs to any of the training data. It could be images, music, text, or any kind of data we have with respect to this. So GAN, as we all know, that it consists of two parts, that is generator as well as the discriminator. So this is the architecture of that, where we will be introducing random noises to the generator to generate fake images, where discriminator will start identifying the fake images. So it will send back to the generator by stating that it is a fake image, and generator will try to solve it by adding more reality to that. So that is how basically the generator adversarial network is working. So that's what the explanation is given. So generator receives the random noise. Z is the representation of that for generating a fake sample. So discriminator could see both the real and fake data and tries to classify them. Based on the feedback, it will be continue to process this. So it is a kind of play, yeah, min-max game with respect to this particular process. Out of this particular exercise, we will be able to create a realistic image with respect to this. So some of the prominent applications of GAN includes face aging or reconstruction with various aging apps we are seeing in recent days, and the forensic recovery also one of the prominent application of GAN. Art and style transfer is another major area which is benefited out of this particular technique. Super resolution, which will be enhancing the quality of the image from the blurry images. Normally, we used to collect from the security cameras or something like that. Medical imaging highly benefited out of it, because when we have a shortage of data, for example, MRI scans or something, so we can generate a synthetic data out of this data augmentation exercise. And finally, the fashion and product design, which will be virtual and augmented reality based simulations, where we will be able to see the AI generated clothes and how it will be fit into a particular person, and all such kind of applications we are able to see in the today's scenario. So some of the prominent types of the GAN includes the conditional GAN, which has also the generator and discriminator process, whereas it will be working based on the labeled input as we have. For example, if we give 3 as a condition, so it will be generating a handwritten digit of 3. So which will generate an image, but we have to guide it that what category and what we want with respect to that. And on the other side, the cycle GAN, which is unpaired image to image translation, because we have a paired image to image translation as well. So with the similar things, for example, between horses and zebras, or summer to winter, so landscapes, so such kind of things basically are not so relative. And most importantly, there is no pairing between these two things. But the cycle can turn these things into the reality. So what is the advantage of this is, even if we do not have paired images, it will be able to learn to translate between the domains. So that is what the beauty of cycle can. And third one is the pix to pix, which is the paired one, that between the map to satellite or sketch to photos. So all these kinds will be a paired network, which really requires a paired training data to work with this particular GAN, so which would give us a proper outcome. So it always says that provide me an input image so that I will be generating the paired target image. So such kind of way it basically works. Whereas this style GAN is standing out because it was by NVIDIA researchers, which has various versions from 2018 to 2021, which will be basically works on the high quality images and object generation. So it allows interpolation between styles, age, gender, lighting, all the parameters corresponds to a particular image. It will be able to interpolate all these things by generating really a good resolution things. It is a progressive process, where it starts from a small range of 4x4, and it will keep increasing, and it may go up to 1024 cross 1024 from a small 4x4. So in that way, it will be slowly building the resolution. That's how we were able to see to that the results are very impressive with respect to the style GAN. Even we have seen as one of the figure which was generated by it, which was very impressive. Even in the year of 2019 itself, it was the probably the first version style GAN's outcome itself. So right now we are using the advanced versions of that. So the next one is the variational encoders. The second type of model which would be trying to helpful for us to generate contents. So this particular auto encoders compresses the input data into latent space and reconstruct the original input. So already we have gone through about the brief introduction to what is latent space and how it is being created. So in this particular way, we are able to see that this VA is working, and it works on the two contexts like encoder and decoder based one. So if we gives an input, it will be in a position to compress it, and it will be convert it into the latent representation called Z. And from the latent representation, as we could relate that it is in the much smaller representation from the original size of the image, the decoder structure will reconstruct X dash from Z. So X dash is another image, obviously, but we should look into the similarity between X and X dash, that how closely these two things are there. So that's how this particular methodology works, where the encoder does not output a single point in Z, but it will be looking into the overall distribution in terms of mean and variance, where the latent vector representation plays a crucial role in terms of this particular regeneration of the original image. So some of the applications that we have from this VI with the domain perspective, we will be able to generate synthetic scan data for rare diseases when it comes to the medical imaging. We can have creative tools for handwriting and sketch generation, anomaly detection, as well as the compression. So compression is one of the important thing when it comes to the image processing, and it would provide a better way to handle with respect to that. So now the comparison. So what is the comparison between VAE and the GAN, what we have discussed? So the first one is a probabilistic approach, encoder decoder framework, whereas the second one is the deterministic approach, where we have the generator and discriminator based approach. So whereas the quality of the output could be blurry when it comes to the VAE, whereas GAN is very sharper, we will be able to get it. In terms of diversity, if your data is very diversified data, then we could go ahead with VAE, because which is good in handling that, whereas GAN would suffer when it comes to the diversified data, and the mode of this particular process would collapse. So this is what the example of an image which is being generated, regenerated with VAE as well as GAN, where we will be able to see a visible difference between these two image creation. So the concluding remarks between these two, as we have seen that VA's brought probability to deep learning imagination process, but they are not perfect because we are not in a position to get sharper images. So that's the reason why we have moved towards GAN and eventually towards the diffusion models, the third type of model that we are going to discuss next. So diffusion model is the third type of model for the Gen AI, generative AI, where we could create newer contents in terms of images or the other contents that we could see in the future. So this particular diffusion model is a little different from the GANs and VAs that what we have seen. So it has been widely used in the recent time, but it has certain limitation as well. So the GANs and autoregressive models usually generates sharper images and more diverse also when it comes to VAE, and which may produce stable output also. But they avoid GAN mode collapse is one of the drawback with respect to that. And surpass VA's blurriness is another issue with respect to that. And this particular diffusion model stands in between these two things, and which can scale better than the autoregressive model, and making this as a state of the art technique for high quality controllable image and as well as for the video generation. So that's how we will be able to see to this particular thing, which could act in between the two drawbacks we have with respect to the previous two models. So when it comes to the process of diffusion model, so we could imagine by starting a crystal clear image where we will be adding tiny bits of random noises here and there. And we will be doing this as in a step-by-step process until it is getting a pure static image. So the model learns to reverse this particular process because it was added in a step-by-step procedure. So it is possible to reverse back to the original position. So when we turn this around, we will be able to look into the coherent image as well. So that's how the diffusion model works, where in the forward process, we will be gradually corrupt the data with Gaussian noise over T number of steps. After enough steps, the data becomes indistinguishable from the pure noise, because that's what the purpose of this particular diffusion. So when we are able to achieve this indistinguishable format, we will be able to go for the next phase of this particular process, that is denoising, which is also called as a reverse process. So this particular neural network learned to predict and remove the noises which were added at the each step, so that we will be able to start from the noise to iteratively denoise it to reach the final stage of the image. So we will be able to see both the forward process as well as reverse process with respect to this particular task that we do as part of the diffusion model. We will be able to ensure the content generation. So there are several diffusion models are there. So DDPM is one of that, which was introduced in 2020 by Ho et al., which was denoising diffusion probabilistic model. So which is the original formation of modern diffusion model, because this is the base of that, the original diffusion model. As it was explained in the previous slide, that it uses a Markov chain of T steps in order to introduce the noises towards that. At each forward step, it adds a small amount of Gaussian noise, like it was explained earlier. So we will be subsequently reverse this particular process by subtracting it. So this particular network is trained using an mean squared error loss between the true noise and the predicted noise, because while we forward and reverse, what is the deviation that we would be getting? And when we slowly blurring an image until it becomes static, this DDPM learns exactly how to unblur each step in reverse. So that's how this diffusion model, the base model of that, basically works. But what is the drawback of this particular DDPM? The base one is a very slow process, because we were working on a step-by-step manner. So step by step, when we try to address this particular steps, it would take a lot of time to execute this particular process. So that's how we have the next type, which has come in the year of 2021 by another set of researchers like Song and others. They have introduced DDIM, which is denoising diffusion implicit models. So which removes the strict stochasticity of the reverse process, because the stochasticity ensures a step-by-step process of reversal. Whereas here we will be in a position to see to that this kind of things would jumps between the steps without losing much quality. So we ensure the process to be executed as quick as possible, unlike the DDPM, which took a lot of time for the execution. So this could ignore and jump several steps, so that we will be in a position to ensure that the content generation would be faster when compared to the previous. For example, if DDPM took 1,000 plus steps in executing this DDIM would take hardly 20 to 50 steps in terms of the execution. So which is a deterministic one, because we will be able to ensure that the information are not lost much with respect to that. So the later one, 2020, 2021. So 2022, there is another diffusion model which was introduced by Rombach and others, the researchers, in the name of latent diffusion model. So which is working in pixel space. As we all know, what is the latent space? Latent space is always a space which will be bringing down the original images to the latent maps, which will be relatively a much smaller representation. For example, 512 cross 512 images we are working with, the latent maps may have only 64 cross 64. So such kind of a smaller representation, we will be able to do that. Obviously, we can utilize the VAE, that variational auto encoder, which would be helpful for us to compress the images into the latent space. So that's what we have seen as an advantage of VAE also. Beyond the content generation, it would be very helpful for us to compress the image as well. So which could run the diffusion in the latent space instead of the original space, which would be smaller and the lower dimensional representation. So which would be ensure us to process the image even much quicker, that if the first one takes 1,000 steps for a larger representation, this one will be taking very lesser number of steps with a very smaller representation of the image, so which could further speed up and which may give results in the lightning speed. So what is the advantage? The absolutely the quicker execution is the most important one. Apart from that, the memory efficiency. So we may run on the consumer's GPUs itself, because we are working relatively on the much reduced space in the lower dimensional space, which also enables conditioning on text sketches as well as depth maps and all those things. So the next thing that we will be quickly looked into is the video generation from the three models that we have discussed with. We will be able to extend those team models for the video generation as well. So video, when it comes to video, it is the extension of images. It is not going to be completely a newer representation. It is an extension of images. So first, let us understand that. So the task of generating sequences of video frames. So here we will not call it as an image. Here we will be calling it as video frame. So a frame consists of several frames constitute towards a video creation. So which should be visually realistic as well as temporally consistent. But when we say that it is the extension of image, here the challenges are quite high, because we need to work a lot with respect to this. So normally an image is a 2D representation. We have only two-dimensional representation, 512 cross 512 or 1024 cross 1024. But in video, we will be having the third dimension, a temporal dimension or time dimension, that we will be adding it to it. So it must maintain continuity of characters, objects, lighting, motion across the frame. So it has a lot of challenges when compared to the image creation. So when it comes to the dimensionality explosion, so we will be able to see that images could be 256 cross 256 corresponds to close to 2 lakh values, whereas if you look into the same 256 cross 256 video multiplied by 30 frames, 30 frames is a very, very, very small number. It could be a few seconds of video, we could say. So which will be equal to 2 lakhs multiplied by 30, which is equal to 60 lakh values will be there for just a 30 frame 256 cross 256. So we will be able to see a explosion of dimensions and values that we are going to have in terms of its representation. So that is what the very big challenge when it comes to the handling of the video related data. So in video generation, so we have to look into several aspects, starts from the temporal consistency, which may ensure the smooth transitions. For example, if a car is red in frame one, it must remain red across all the frames till that particular shot or video gets over. And motion understanding, the physics behind each object, how it moves and all those things we have to take care. Data scarcity is another bigger problem when it comes to the image-based data set. We may have billions of data sets available, but video data sets are not much available. There are very fewer and smaller with respect to that. And finally, the computational cost will be huge when it comes to training a video model, which may require 10 to 100 times of the normal GPU memory we require to process for image-based models. So such kind of things poses larger challenges for the video generation. So what are the key paradigms when it comes to the video generation? GAN-based video models are there, which are short and looping animations. Diffusion-based video models are there, where we start with the noise, then gradually denoises into the video frames through the temporal layers and the latent space diffusion. And yeah, we have the transformer-based video models as well, which will treat video as a sequence of patches like the transformers, like a vision transformer. If you have referred to that particular way, it will be trying to use the attention mechanism to look into the long range dependency or model relationship across the space and time. So this particular GAN-based thing, which may be looking for the temporal consistency, whereas it captures the motion across a few frames, but which may struggle with the long-term dynamics what we have in terms of transformer. So which may be difficult for us to get a very good videos because repeating clips may have limitations in terms of generating it. So this is the comparison between GAN based, VAE based, as well as the diffusion based with respect to that. Whereas the GANs are mapping the noise to frames via generator, whereas VAEs encode frames into latent space and decode them back, whereas the diffusion models gradually transforms noise into frames through iterative denoising process, where each method represents a very distinct approach to generating the data when it comes to the video generation. So next, when we quickly move into the hybrid or multimodal models, where we have the combination of different data between text and video, image to video, video to video, or audio plus video to video. So in that particular way, we will be in a position to generate video. It is a very, very challenging thing. Someone may give a text as an input and they may ask us to create a video, means the creators or the tool. With an image, a video may be asked to be created, and from video to video in terms of editing, style transfer, extending clips, yeah, that could be possible, as well as audio separately and video separately may be given as an input, where in the video, the lip sync and music, all these things needs to be synchronized. So all these are going to be coming under the big umbrella of the video generation. So where we may be looking for the content in terms of multimodal model, in terms of handling this towards the creation of the videos. So already we have the state of the art models for the video generation for all such modalities we have discussed in the previous slide, like OpenAI Zora, where text to video, as well as we will be able to look into the various things will be satisfied when it comes to the dynamics of the video. And Runway Gen 2, Google, Finaki, as well as Meta's Make a Video. So all these research ecosystem are generating long as well as evolving videos directly from the either from the narrative prompts or enabling the continuous storytelling from the text, or the prototype models like showcasing the Meta's research in text to video. All these are producing short but visually pleasant video clips out of these kind of exercises. So next, when we move into the next part, that is audio, because text, image, video, all these we have briefly discussed, whereas audio is also an important part, because audio generation also covers in terms of speech synthesis, sound effect creation, as well as music composition. So all these is possible when it comes to this particular generation model, where the music generation requires many things, not only about the lyrics and the tune or something. It has to capture the pitch, rhythm, timbre, instrumentation. So all those things it has to be looked into. So in such a way, it will be it has to create a continuous high dimensional as well as temporal data, which could be working along with the text and static images. So when we looked into audio very specifically, it is inherently continuous, because we have to see a continuous outcome with respect to the audio generation as well, similar like the video. So which is a more complex one when compared to the images that we have discussed little earlier. So unlike the other things, audio signals very smoothly over time. So which requires models to capture the fine-grained temporal dynamics. So in terms of frequency patterns as well as the contextual coherence. So all these things are required for the realistic generation of an audio clipping or the music that we could talk about. So when it comes to again the audio generation, so we can discuss again about the same models we have been discussing about with respect to audio. When we looked into the audio regressive model, the generation of audio waveform or spectrogram will be a step-by-step process with respect to the corresponding time-based dimensionality, which captures the temporal dependencies effectively, but can be a slow process for a very long audio that we could generate. Where some of the examples like a deep mind-based WaveNet and open AI-based NewsNet are utilizing the autoregressive model for the generation of the music. VA is also it's playing its role in terms of the generation of the audio. So where it can learn a latent representation like what we have seen in the images in terms of embeddings of spectrograms, which could be the representation that it could work with. Whereas a decoder would try to reconstruct the audio from the latent code that it generates, similar like the images or videos that we have discussed about, and which is great for the style interpolation, where the blending of two instruments and tones and all those things, the VAs are doing a much better role when compared to the other types or other modalities of data it worked. So it learns the compact latent representation in terms of sounds and other things, which could capture the underlying structure. So that is what the beauty of this particular approach. So which will be capable of producing outputs, which may still lack some sharpness or fine grained details when compared to the other state of the art techniques. So diffusion models are also having its role in terms of the audio generation, where our diffusion model for audio work by progressively adding noise like the other diffusion model to spectrogram, and then training a model to reverse the process through denoising, like what we have seen earlier. So this iterative approach produces a high quality audio, a stable audio, which could outperform all other modalities we could see with respect to the other models. So audio LTM is one of the prominent one which works based on the diffusion model, which runs in the diffusion based latent space for faster music generation. So this is the music generation pipeline in general, where we will be giving the waveforms as raw audio samples as an input. The spectrogram will take care of the time frequency representation, And MIDI will be the representation of the music actually in terms of notes, durations, instruments that will be taking care of that, where we have symbolic models as well as acoustic models, which will be working on a different perspective. Whereas we can have the hybrid model also by combining the symbolic one as well as the acoustic. So that's all about the audio, where the future trends of audio, like multimodal music generation, where music along with the lyric is going to be a challenge. And beyond that, music with the created video, that is going to be even more challenging. And all these could be done with the image input or something. So that could be the future of this particular thing. Whereas interactive AI composers, already some of the prominent composers across the country started using AI as a collaborator for the music generation in terms of voice and other things. So generative audio for AI PR is going to be another game changer for that particular field, as well as AI voice cloning and deep fake detection are another future trends corresponds to this particular thing. So next, when we move into the multimodal generative models, quickly, we all know that it is truly a multimodal era where we have to work along with the different modalities like text, images, audio, video, and all those things. A multimodal one would be working along with both of this. It could be a really challenging one, but it has to learn a cross-modal relationship. It has to understand how concepts appear and relate across the different sensory formats. So basically, a human perception is inherently multimodal because we process sight, sound, touch, and language, all these together. So AI is still a challenging one because when we introduce this multimodality, it enables richer and more context-aware generation. So a model doesn't just generate a dog's image, it can also create the walking sound and a descriptive caption. So that is how we could understand how the generative content, by combining all the different modalities that we could have in terms of the images, in terms of the text, in terms of the sound. So multimodal generative models, it has to map different modalities into a shared vector space. That is a very challenging one. For example, a text red apple is encoded into a vector, and an image of a red apple is also supposed to be encoded into a vector. And most importantly, these two vectors should align each other, which means it has to be trained in such a way that both the vectors should align closely with each other, so that it can understand that these two things are relevant, which means a text red apple as well as an image of a red apple. So that is what quite a challenging thing when it comes to handling the multimodal generative models. So one of the popular multimodal model is two tower or dual encoder model, which is quite popular. Basically, it uses separate encoder for different modalities. Where, for example, one encoder for text means one encoder for image or video or audio. So two different encoders, we will be able to use it here. So in that particular context, each encoder transforms inputs into vector embeddings, and training aligns with these embeddings in the same space, enabling tasks like text to image retrieval or the cross model matching. So that is what the most important thing when it comes to this particular process. So the training objective of this particular model is contrastive learning. For example, CLIP is a very popular technique under this called as contrastive language image pre-training. An example like what we have discussed in the previous case could be very good fit into this. So encoder decoder model is another one where one modality as input which could taken as an to the encoder, whereas another as output to the decoder. For example, we want to map text to image. The text we will give to the encoder, and the image we will provide it to the decoder. So where the mapping would be done like a DALL-E 2 from OpenAI. So all these are working under this particular aspect. Whereas the unified transformer is something unique when it comes to treat all the modalities uniformly by converting them into tokens, whether when it comes to the text, or it could be image patches, or it could be audio spectrogram, whatever it may be, it could process them within a single transformer. So that is what we are calling it as unified transformer, which enables the seamless multimodal understanding and generation. So some of the examples like POMI or Flamingo or Cosmos One, all these are working in this particular aspect. So these are all some of the popular key multimodal examples like text to image. We have several popular tools are available. Text and video, we have another set of things. Text and audio, we have another set of things. Whereas multimodal chat, we have Gemini, GPT, and other things. Recently, we have the launch of GPT-5 as well. So all these are working on this particular aspect. So what are all the future trends with respect to this particular aspect is already we have discussed a lot about scaling. So scaling is one of the major issues because scalability needs to be ensured always, especially when we work on the internet domain. So all these are available in the internet, and we do not know how frequently the data is being generated, how huge the data is going to be generated. So scaling going to be one of the major issue which will be the focus in the future. So multimodal and unified, we have discussed we have discussed about that, which is going to also have a long way to go with respect to these two aspects. And beyond that, the edge GN AI is also going to bring generative AI to mobile devices, IoT, and edge systems. So because we are no longer going to have completely depends only on the cloud, even though the data is huge and all those things. But the turnaround time always a concern when it comes to work with the cloud. So the modalities are now moving towards the edge when compared to the cloud. So it is needs to be very properly incorporated into handheld devices like mobile devices or to the IoT based system, or which enables the low latency, privacy, and energy efficient applications without a heavy cloud reliance. That is something very, very important because energy, even the OpenAI head was recently sharing that even if you say please, sorry, thank you, all those things, how much amount of energy is being consumed for processing those words. So he has advised and requested the user to not use such kind of words. So which is also one of the reason why we will be looked into the edge based Gen AI in the future, as well as the agents and tools we briefly discussed earlier, which is also going to be the next step in this particular process where Gen AI models evolves into autonomous agents that plan, reason, as well as use tools or APIs to complete some of the complex and real world tasks. So that is what going to be the trend with respect to this particular thing. And beyond that, we could see that true any to any generation, a true really a complete solution any to any generation is going to be one of the future trend which could seamlessly translate between any two modalities. Interactive agents not only acts, but it could listen, see, speaks, as well as acts in real time is going to be another path breaking thing which is going to come up in the future. And third one is a neuro symbolic multimodality, so which is going to combine the reasoning with perception. So as of now, we all see to that most of the AI models are like black boxes, which would be giving us results in some form that there is not much interpretability of the results, or not much reasoning with respect to certain things, that why it has given a solution, it has given an output, or all those things. So such things needs to be taken care. That is going to be the future. And finally, the personalized multimodality. So it will be changing from individual to individual. It will be depends on the individual's interest. It will be more adaptive towards the generative outputs to a one's preferences, users' preferences, style, needs, and all those things. It could be extended to the kind of education the particular user has. Somebody would have been highly educated, somebody would have been a IT guy, somebody would have been a student, somebody would have been a farmer. So it depends on the person. It should not be giving the answer for everyone in the same way, because everyone's understanding and maturity will be changing from person to person, ages to ages. So all these kinds of things should be properly taken care in the future. So with this future trends, we will be moving towards some of the challenges and limitations of generative AI in the present day scenario, that someone could work on this particular area as part of their research or something. So the first thing is data quality and bias, whereas generative AI models learn huge amount of data collected from the internet, books, articles, images, videos. The input could be anything. We cannot validate every single piece of information available in the internet. We cannot correct all the mistakes in that. So in that case, if the data contains biases, errors, stereotypes only about a particular gender, only about a particular community, only about a particular language, or something like that, or there are inaccuracies. So all those things will completely spoil the model that could develop out of those sources, which could be a biggest challenge, because biased AI outputs not only harm the credibility, it will be completely damaging the trust over such kind of system. Survival of such system would be completely questioned. So in that particular case, so such kind of misinterpretation, misrepresentation towards a gender, towards a culture, towards a symbol, all these kinds of things could be very much possible, because data quality is going to determine the outcome or quality of outcome of these kind of generative AI models. So second thing is computational cost and energy use. So we all know, very well aware of the training process, which requires enormous computing power and energy, which is going to be biggest threat in terms of the CO2 emission, which is also depleting the ozone layer and all those things. So which can be equated to multiple number of cars running throughout the years, which could be mapped to that much amount of depletion in terms of the emission of the CO2. So even after training, running these models, especially for high resolution images or long videos, can be expensive is another issue, and which limits accessibility, that only big technological fronted companies alone can afford to train such kind of cutting edge model. And these kind of things may not be feasible for an individual or a small scale sectors. So such kind of limitation is something to be really worried about. Third one is the hallucination, as we have briefly introduced in the beginning, that in terms of inaccuracy, which may generate wrong facts, citations, images, which may look like real, which may be looks like authentic one, but maybe completely a false information. So such kind of trust in AI, such kind of things will decrease the trust in AI if users repeatedly encounter wrong or misleading information. So which may be an issue in terms of intellectual property and legal concern as well, because AI-generated content may unintentionally copy from the copyrighted works. So, which is also possible, especially a music generation model might produce melodies extremely similar to an existing song, which we may not know. For example, it might be belongs to other part of the world, but here if you are generating and if you are using, which may create a violation of intellectual property and which may create legal concerns towards that. And ongoing lawsuits and policy debates also could reshape how these models are being trained in that particular case. The next one is the ethical use and misinformation, where generative AI could be misused for creating fake news, deep fake videos, or impersonating individuals. That is another major issue in the recent times, that the circulation of fake news and especially the deep fake videos in the face of a celebrity. Even it happened in the past. We are all know about that. Such kind of things, it will be very difficult to stop, because before someone identify it as fake, it will be spread across something like a viral thing, that it will be very difficult to delete all its digital footprints. That is something we could see as on the other side, a challenge with respect to that. For example, a deep fake political speeches or fake audio of a CEO announcing false company information. So all these kind of misuses may cause financial losses, reputational damages, or even social unrest also may happen because of that, because it will take some time to validate and authenticate that kind of information within that particular time frame. Anything could happen in that particular way. And the final challenge is, as I have informed a little before, about its lack of explainability, because AI could not explain most of the cases, that why a particular output was generated, why a particular decision was taken, why certain contents were generated in that particular way. So in that particular case, we could see to that lack of explainability is a problem with respect to the generative AI itself, because it is very hard to debug or improve things, and difficult to ensure the fairness or accuracy with respect to that. If generative models also reject certain inputs or favors others, that one may not know why such things happen. So it will be very difficult to backtrack and solve that particular kind of things. And this also will make the user to hesitant to fully trust such kind of system. So all these are the real challenges and the limitations corresponds to generative AI. And the final part of the quantum perspective towards generative AI as a concluding things, concluding remarks. Let me go with it's already it took almost 1 hour 26 minutes. Okay, let me finish in another 4 5 minutes. That whatever we have seen as generative AI models like GPT or diffusion model, which requires basically massive amounts of computing power, as we have seen as one of the biggest limitation and a challenging towards that. So training them takes weeks, months of time, sometime, which requires huge data centers and basically requires millions and dollars of money to be spent on that. So on the other side, we know that quantum computers process information completely in a different manner using qubits compared to the 0 and 1 system, which could represent multiple states at once, which could be taking into the superposition, which may allows them to explore many possibilities simultaneously, instead of the regular step-by-step process that we have been discussing so far. So in that particular perspective, quantum could make Gen AI faster, more efficient, and capable of solving some of the problems that are currently out of reach. That is what we are seeing with respect to some of the fields where we could see there is a possibility of quantum to get into that with the help of Gen AI. So first benefit, it could get us efficiency in training because quantum methods could drastically reduce the time and energy needed to train such huge models. Second one, it could have a better creativity because the quantum's ability to explore many states at the same time could help generate more diverse and creative outputs out of this particular exercise. And it could also address the complexity issue that we have discussed. Like it could be very helpful in areas like drug discovery, finance, or climate modeling, which are need of the hour, where there are billions of variables are there, where this kind of approaches would be completely helpful for solving some of the scientific problems, which is the need of the hour. So from introducing quantum towards helping the Gen AI, we will be moving from the present scenario as content creators. Now we are seeing Gen AI as a content creators to move from present position to scientific problem solver. So which is going to be a huge achievement in the field of artificial intelligence or the entire technological front. So that is what quantum may take Gen AI to that particular position. And when it comes to the research prototypes and early efforts, even though it is in the very early niche stage of the particular process. So this particular hybrid models where researchers are combining quantum circuits with the classical neural networks called quantum machine learning, so which is already in action. Some of the examples of experiments like quantum inspired GANs, Q GANs, where the generator runs partly on the quantum hardware, whereas using quantum systems to sample complex probability distribution. So something Gen AI relies heavily on the particular process where we will be able to use the quantum systems to step in to solve some of the complex things by ensuring some of the advantages that we have discussed in the previous slide. And when we looked into the future vision of the entire things, what we were discussing about, we could, because anything could be part of the vision. So we can also have a vision like we may have in future a scalable Gen AI because recently we had GPT-5. So we may have GPT-10 maybe after 4 or 5 hours, which could be trained in hours instead of the months of time the GPT-5 took in terms of the training process. So, which could be something, yeah, very, very revolutionized thing. Because if you could train a LLM within hours, it was going to be a biggest path-breaking innovation with respect to that, where we could see that with the innovation of bringing quantum into Gen AI, which may be possible. Second one is personalized Gen AI, where we would be calling having the faster models which could run on smaller hardware, even on personal devices, as we have briefly discussed in the edge-based Gen AI. So where we can run those models in mobile devices, IoT devices, and all those things. So which could be probably with a smaller hardware instead of the larger hardware. And in terms of scientific breakthroughs, we could see that designing of new drugs by simulating molecules more precisely, or creating sustainable materials, or optimized financial strategies through these kind of scientific breakthroughs by combining this quantum with respect to the Gen AI. So in the long-term perspective, the quantum along with Gen AI could shift from today it is being chatbots and R tools to become problem solving partners for the humanity. So such a large vision we can have in terms of this quantum and Gen AI that what we are discussing today. So with this strong note, let me conclude that generative AI today feels revolutionary, but in the quantum era, it might look just the warm-up act, right? So what we are seeing today is just a warm-up act, and we may see, or we have to wait and see the real potential outcome of the generative AI in the future. So where the quantum computing could unlock a new level of creativity and intelligence by pushing Gen AI from being just like a tool for expression to a true engine of discovery. So we will be able to see all the discoveries will happen because Gen AI itself is a generative thing, but when it will become a truly generative one by discovering some newer things, we will be able to see in the quantum era. So that is what this figure also says, that today's Gen AI is a classical one which has the higher computational cost, limited creativity, and very difficult with the complex problem, whereas future Gen AI, which could be powered by quantum with the increased efficiency, enhanced creativity, as well as which could have the ability to solve some of the complex problems that we could not solve at the present day scenario. So with this note, with this conclusion, I just want to conclude my discussion. So thank you very much for your patient listening. So now let me go to the organizers for any doubts.
Participants, if you have any queries, you can ask. Participants, do you have any doubts? I posted the feedback form. Kindly fill the feedback form. I posted in chat as well as in the WhatsApp group. Any queries?
Sir?
Yes, sir.
My question is beyond this topic. Okay. My question is, if I am a data science in masters, okay, and
Yes,
now
sir.
I want to PhD in this era. Is that possible to do?
Yes, sir, definitely, sir. It is like all are now working together. So you cannot completely rely on the Gen AI alone. So you can take the overall data science or artificial intelligence where you can bring Gen AI or agentic AI. So whatever edge, whatever the possible things are there, you can take it up. So in the present day scenario, we could see that the existence of all these together can solve some of the complex problems. So if you take a research problem, you can very well utilize all these things. So for example, Gen AI, you can utilize for the data. Basically, if you work on data science, you need a data. Not all the data that we get in the real world scenario are perfect or balanced or something like that. So where you can incorporate Gen AI, then you can bring deep learning or machine learning based models that could be helpful for you to solve a particular problem, which could be maybe deployed into a mobile device or something where you can bring the edge computing. And when we talk about the interpretation of the results or explainability, we can have XAI techniques to explain your results. Like that, we can bring an integrated environment where you can utilize all these aspects in your research.
Thank you, sir.
Yeah, thank you, sir.
Hello.
Yes, sir.
Sir, is there any possibility to develop lightweight models, sir? Lightweight LLMs?
Sir, lightweight LLMs are right now not possible, sir. We can have SLM instead of that. When we say large language model, it will be in a position to answer for any kinds of query. So instead, recently we have RAG retrieval augmented kind of things are there. So where if you work on that, you can work with respect to a particular field. For example, if you are in education, so you can have a small language model with respect to only education. For example, students looking for higher studies, students looking for the employability related training or something like that. So where you can bring a particular model, so that could be a lightweight model that we were expecting. But as of now, we cannot have a large language model because it requires a lot of computational
Computation.
power as well as resources.
Sir, what would be the final the destination of Gen AI, sir, according to you?
Sir, it is a never-ending story that AI may be there in different forms. So as long as AI is there, everything will be there. So not only Gen AI, even the from the rule-based system to machine learning to everything will coexist. So that is the kind of ecosystem it is, because the progression of each particular thing we are able to see throughout all these years. And my humble view is also that even after 10 years, everything will be there, as quantum is going to bring more changes towards the approaches, the way at which the computing is going to perform. We may be able to see to that, as I have mentioned in the presentation. As of now, the usage of Gen AI is very much restricted for the content creation, like many are using for assignment preparation. Some are using for creating some context, some are using for time pass. So in that context only, as of now, maybe a real potential of Gen AI, which may come out after 5 years or some time. And it may have even more time to progress further, that we have to wait and see.
Yeah. Sir, I have one more question, sir.
Yeah.
You nicely given, the answers for my questions. One more question, sir. Sir, who can be
Yes,
the
sir.
regulatory body for this generative AI application, sir, in the future days? Or coming, or
Sir,
currently, is a regulatory body, sir,
yes,
for
sir.
this?
AI ethics is an issue, sir. AI ethics right now, we do not have any strong rules or something. So even sometime before, we have seen an actress deep fake image came, and not much to be done with
Copyright.
that. Within that particular time frame, it went viral and all those things. So as of now, AI ethics is again in the very beginning stage, because only in the last 1 or 2 years we are seeing violations and other things. And very interestingly, if you would have read a newspaper in one of the company in the Western country, the AI has started lying to its owner.
Mm-hmm.
So it's not about a human being now. So now, after AI getting the superpower, it has started like a boss to the human being. Like if you would have watched a movie
Okay.
which was taken in 2010. So such
Mm.
kind of things now becoming reality. So it's not only about human being, even AI ethics itself is going to be an issue in the future, that what we are going to give it to AI, what not we are not supposed to give, all those things are going to be a real challenge. As of now, even I don't have much idea about what kind of
Regulation.
regulations and other things we have with respect to
Mm.
this. It's now AI is having a free hand, that anything it could do.
But mankind, we have to look into those aspects now, sir,
Yeah,
because it's
definitely, sir. Already
currently,
AI
but
is killing
because currently
many
what we are
jobs.
living, it is what we are living today. It is the efforts by our ancestors or our previous generation people, and tomorrow for the next generation we have to give some contributions. So if if we create this type of environment, I think we are in a wrong direction. So I think some the top people or some authorities, they have to sit together and
Yes, sir. The
they have to
policy
plan
makers
immediately.
should closely look into the all these aspects, and they could only regulate all these things. Otherwise, definitely
Yes, sir.
anything could happen in the future.
Yeah.
Yes, sir.
Because today, if you go to, because I'm in the education field, if I ask any assignment to my students, immediately they go to ChatGPT or Gemini, they collect and submit without even
Yes,
thinking
sir.
anything.
Yes, sir. Everywhere the challenges are there, and we have to coexist with this particular. We have to practice always as a teachers. We have to practice to coexist with such a ecosystem, and we have to also come out with a solution how to battle these kind of things. So it's really a challenging scenario right now.
Mhm. Okay, thank you, sir. Nice talking to you. Thank you,
Yeah,
sir.
yeah. Thank you, sir. Thank you.
Sir,
Participants, any other queries? Yeah, sir.
sir, I have one more question. If you are
Yes, sir.
comfortable.
Yes, sir.
Sir, what is this scenario now? Because you have attending lots of seminar and giving meet lots of people
Yes,
who
sir.
is joined with AI industry and all of those things. Sir, is
Yes,
that
sir.
possible to like deep seek is
Deep
possible to
seeking.
make like deep seek have made by the China. Is that possible
Yes, sir.
to
Yes, sir.
any AI model or AI that make by India
Sir,
or
now India is also working on that particular perspective. Recently, also there was a call for our country, and people are working towards that. Maybe in another 6 months or 1 year, we will come to know about that, sir. Because when China was working, nobody was aware of that they were working. But surprisingly, they announced, and the capabilities were compared to ChatGPT as well, and they made it as a free version for all of us. So we also sincerely hope that one fine day India also will come out with its own ChatGPT or whatever it may be the name it is going to name it. India is already working on that, sir.
and sir, what about the some of the students have asked me that lots of job have been replaces like a few days
Yes,
ago
sir. Yes, sir. It
work
is the job profiles are changing, and people who are not cope up with the latest developments are facing that particular problem. So definitely, students will be having a lot of anticipation with respect to these kind of things. So we can advise the students that what is there today may not be tomorrow, but we should be adaptive to all kinds of changes. So in that way, we have to advise students, because even we do not know that our job will be available after 10 years or 15 years. So this is how the fast changing world. So in that way, AI is doing a lot of transitions across the domain. So if you see, not only in the IT industry, almost every other industry is suffering. If you look around the world with the job losses and other things. So we have to look for the changes that are happening around us, and we have to also dynamically adapt to all those changes which are coming in the future.
Thank you so much, sir. Thank you so much.
Yeah, thank you, sir. Thank you, sir. Nice talking to you.
Any other questions, participants? I think the questions are over. Vincent,
Okay,
sir, thank you so much for the session, sir, and thanks for accepting to present here. And the session was very informative with clear contents, and the correlation between the quantum computing and GenAI was correctly presented. Thank you so much for your time, sir. Thank you on behalf
thank you,
of
ma'am.
RUAS.
Thank you, ma'am. Thanks for the opportunity. Thanks for giving a session on this particular current topic. Thank you very much.
Yeah, thank you, sir. Thank you so
Ma'am.
much.
Thank you.
Participants, it's the end of the session. We can leave and we can meet in the tomorrow's sessions. Thank you all.
Thank you, ma'am.
Yeah, thank you.
Thank you, ma'am.